Okay ji, Bismillahirrahmanirrahim ji. Welcome to week 4 in steel structure CE 409. Okay, in today's lecture what we are going to discuss is mentioned on this slide. So we will keep on discussing the connections, but in today's lecture we will discuss the slip critical bolted connection, and then we will discuss the welded connection. But before discussing the welded connection, we will go through terminology of welding. We will go through the types of welding, different symbology which is being used in order to identify different type of welded connections on the drawing. Okay, then we will have some discussion on stresses which are induced uh, in the welds, and then we have code requirement. Okay, this code requirement I have taken it from the Professor Dr. Tanaim Saab's lecture, so I have added it for the completeness in this lecture. Then we will have some examples, design examples on welded connection. Okay, if you can remember from your previous class that when we were discussing the bolted connections, there are two type of bolted connections. Okay, the first one is we discussed that the bolted connections are of two types. The first type is, let me grab my pen. Okay, where's the pen? Okay, yes. We already know that the bolted connections are of two types. We bolted connections, if you remember, bolted connections. They can be bearing type bolted connection. Okay, bolted connection. Okay, and we have the slip critical bolted connection. Okay, so in this class we are going to discuss the slip critical bolted connection. And if you remember that there are three types of bolts. Okay, if you remember from previous class, like we have ordinary bolts which are represented by or designated by A307, and then we have high strength bolts. Okay, high strength bolts are classified into two categories. We call them type A or group A. Okay, type A, and their representative is A327 bolts. Okay, then we have type 2 bolts. Okay, it has A409 bolts. So these are the high strength bolts. These are the high strength bolts. And for slip critical connections, we use high strength bolts. Okay, so this is just a refresher from our previous lecture, what we have discussed in our previous lecture. So today we are going to discuss that slip critical connections first. And in this slide you can see that this slide is showing an expression. Okay, this is an expression which you can use to evaluate the slip resistance of bolts. Okay, slip resistance of high strength bolts in a slip critical connection. So over here you will see that this equation consists of this equation is a function of friction coefficient. Okay, it is a function of du value. Okay, it is a function of hf factor, which is a filler plate function. It has it is a function of minimum pretension in the bolts, and it is this value is this variable is representing the number of shearing plane or number of slippage planes. Okay, so the description of these parameter is provided on this slide. Like in this equation, the phi value can take three values. Okay, depending upon the hole sizes. Okay, like for example, we have a normal hole. Okay, normal hole. So the phi value for this type of hole is 1. Okay, if we have a slotted hole, elongated hole, so this value can take a value from this variable can take a value from 0.7 to 0.85. depending upon that if the applied load is in what is acting transverse to the longitudinal part of the hole, or is it applied along the elongated part of the hole. If you have this type of situation, you have to use this value. Okay, if the load is applied along the elongated part of your slotted hole, so then you have to use 5.85. And if the load is applied perpendicular to the elongated size, so we will use a phi value of 0.7. Okay, is that clear to all of you?
Yes, sir.
Okay, I'm sorry, class, I don't know how many people are you. You can try to learn something. Now, the mu value, there are two mu values, like where from where we will select the mu values. There is a table on the next slide. You can select the mu value from this table, okay? This mu value can take a value 0.3 and 0.50, okay? The mu value will be either 0.3 or it will be either 0.5, okay? So it is, will if we it takes a value of 0.3 for class A type, and class A and class B type are representing the condition of faying surfaces, okay? Conditions of faying surfaces. So what is meant by faying surfaces? You know, like you have this type of plate when you are connecting two plates. So this surface we call faying surfaces, okay? And this faying surface definition is given here. It can be class A or it can be either class B. If it is class A, so it is unpainted. Both are unpainted steel, okay? One is a mill scale, okay, or a coating of blast clean steel, okay? There is a coating of blast, okay? Over here you don't have that, okay? So when you see class A or class B, you should immediately recognize that mu value will be 0.3 or mu value will be 0.5. So we finished discussing this mu value. We finished discussing the phi value, okay? Now in this equation, this is a similar equation. So there is a TB value. TB value is the minimum tension, pre-tension in the bolts, okay? Now this value you can select from here in this table, okay? I can write it down here. This table is for TB value, okay? For example, which kind of diameter you are using in your high strength bolt, you can just come here and you can pick the value. As I told you that there are two type of high strength bolts, group A and group B, okay? So this is the minimum pretension value. T is the minimum pretension value in the bolts, and in order to select the values for the minimum pretension in the bolts or for high strength bolts, you can use this table, okay? Then finally, we have this DS. In certain books, this value can be a DU value, or in some books, they use the DS value, okay? So I will use a DU value, okay? This is a ratio between the minimum pretension and actual pretension at the site, okay? If you go here, du is the ratio of installed pretension to minimum pretension, and this is a constant, okay? This value is constant for all the scenarios, and this value happens to be 1.13, okay? So please remember that, okay? You should not, this is, I have taken it from book, so but I have added this table for mu, so you can just see it on the next slide. Then we have HF value. HF value is for the effect of a filler plate. For example, you are using two members with different depths. So when you need to fill the existing gap with a plate. If you have not used any plates, so HF value will be 1. If you have or use only one filler plate in the joint, so this value will still take a value 1. And if there are two or more filler plates in your bolted or slip critical connection, then this value can take a value of 0.85. Then NS is the number of slip planes, you can see here, and there is a NB. NB means total number of bolts, okay? If you multiply this expression with the NB or total number of bolts in your connection. So you will get the total slippage, total slip resistance of your bore connection. Okay. Okay, I hope it is clear. If you multiply this expression, okay, this expression you will see in certain books, it is in the form of 1.13, and then it is mu, then it is phi, then it is HF and TB and NS. Okay, so NB will be there. Okay, so the du value is added here. Okay, so please remember that this equation you can use to evaluate the slip resistance of high strength bolt. Okay, so pretensioning, if you remember from your previous class, that when we use high strength bolts, so what happens that in order when we pre-tension bolts, what happens that more clamping forces are induced. Okay, that's why we do pre-tensioning of the bolts with certain methods. Okay, so that's what, so this pre-tension is only done for high strength bolt. Okay, high strength bolts, pre-tensioned, pre-tension. Is that clear to all of you, how we can evaluate the slip resistance of a bolted connection or slip critical connection?
Yes, sir.
Okay, thank you very much. So please remember, let me refresh your memories that bolted connection, whenever we talk about bolted connections, so immediately if somebody asks you how many are the types of bolted connection, you should be very clear that there is a bearing type connection, or there is a slip critical connection. Okay, so slip critical connection is is essentially a bearing type connection. Okay, connection. So what does it mean? Like, why we call slip critical connections is essentially a bearing type connection. In slip critical connection, no slip is permitted. No slip is permitted. And if there is a slip, so slippage means failure of your connection. Failure of your connection. So when slippage occurs, so in your connection, in slip critical connection, that slip critical connection is converted into a bearing type connection. Okay, if anybody of you can remember that how many checks we perform in bearing type connection? Checks perform in bearing type connection. आपको याद है? हाँ या ना में जवाब
सर
दे दें
3 सर, एक बोल्ट स्पेसिंग का मेरे ख्याल में
जी।
एच सर 3 सर, बोल्ट
Yes,
स्पेसिंग, एच
देखें,
डिस्टेंसेस
generally
वगैरह।
we can say that bearing, we check bearing stresses, and we also it is included in the bearing to check for tearing of edge. Okay, tearing at edge. अच्छा, दूसरा कौन सा हम चेक परफॉर्म करते हैं?
सर एच डिस्टेंसेस के लिए।
वो तो इसमें आ गया ना, बेयरिंग स्ट्रेस में आ गया वो, एज डिस्टेंस, सेंटर टू सेंटर डिस्टेंस, और क्या था, हाँ वो
और
सारा
एक सर
इसमें आ जाता है ना। एक दूसरा चेक है, उसका क्या नाम है? ये बताएं कि बोर्ड्स किस में होते हैं, बेरिंग टाइप कनेक्शंस में किस किस्म की फोर्स उस पे एक्ट करती है?
shearing force.
यस, वी चेक शेयरिंग ऑफ बोर्ड्स or sharing resistance of pores. We check this one, we check this one. अगर आपके पास स्लिप क्रिटिकल हो जाए तो फिर आप क्या चेक करेंगे? स्लिप रेजिस्टेंस। तो ये तीन चेक करेंगे आप स्लिप क्रिटिकल में। अगर आप बेरिंग टाइप है देन यू विल चेक फॉर दीज टू। ओके, क्लियर है जी?
Yes sir.
ओके, थैंक यू वेरी मच। Okay, now we will go to a very simple problem, but please remember that whenever you are asked to design a bolted connection, please remember that whenever you have been asked to design a bolted connection. So what is meant by a design of a bolted connection? आपके दिमाग में क्या आता है? What comes into your mind? What is being required? आपसे क्या चाहते हैं स्टेटमेंट में जब भी आपको कहें डिजाइन अ बोल्टेड कनेक्शन? व्हाट इज रिक्वायर्ड
सर
इन दिस?
बोल्ट स्पेसिंग और एज टू एज डिस्टेंस
वो
वगैरह इस
तो
तरह
ठीक है ना बेटा, लेकिन आपको चाहिए क्या? नंबर ऑफ बोल्ट्स।
से। यस सर, नंबर ऑफ बोल्ट्स।
नंबर ऑफ बोल्ट्स इन द कनेक्शन। ओके, ऐसा ही है ना? लेकिन हाउ वी कैन obtain द नंबर ऑफ बोल्ट्स इन अ कनेक्शन? ठीक है, so the discussion is that if the number should be even or they should be odd. What do you think?
इवन सर।
Yes, because even connection, even number of bolts will result in a concentric bolted connection. Yes, okay. This will result in eccentric. And we are not covering eccentric, okay, in this course. We are just covering concentric bolted connection, okay. But now the thing is that how we can obtain the number of bolts, okay. So we can obtain number of bolts by evaluating the shearing resistance for one bolt. Okay, shearing resistance. So if it is a slip critical connection, then we can evaluate the slippage resistance for one bolt. Why I am saying one bolt? Any idea? अगर नहीं है तो कहीं नहीं तो मैं बता दूंगा।
नो आइडिया सर।
No idea, because in concentric bolted connection, if you calculate, if you determine resistance of one bolt, you can multiply with the total number of bolts to get the total resistance of the connection. Is it clear now, sir?
यस सर।
Okay. Now I have included two examples. Okay, now these two examples will discuss two cases. Okay, okay, right, let me write it down. Like there are two cases for an example. I will show you shortly. Okay, now this example is about slip critical connection. Okay, still we are discussing the slip critical connection. Okay, please remember that how we can obtain the total number of bolts. we missed out the last statement that we have to divide the demand by capacity or resistance of a single board. Okay. Okay, demand means applied load onto the connection. So there will be two cases, as I know we have discussed the slippage resistance. We know that the slippage resistance is this one, phi mu du times hf times tb. So phi value will vary for slotted holes. Okay, so we will see how we can determine the how we can do the strength evaluation of a given slip critical connection. For that, I have to go out of this slide mode. Okay, so we can go there. Okay, there is a document here. Okay, so please read the statement that we have to select 3 by 4 inch. Okay, ASTM 325 strip critical boards with a class A fairing surface. Class A fairing surface means the mu value will be 0.3.
0.3.
Yes. Okay. And this diameter and this board designation, you can go to the table and you can calculate the TB value. Okay, are required to support a load shown when the connection plates are short slots transverse to the load. Okay, it is saying that this is a connection slip critical connection, and the boards they want to use in the connections are 3 by 4 inch diameter, and the applied load is in this direction, and these holes are slotted holes. The shorter direction of the hole is parallel to the applied loading. Okay, so view immediately in your mind phi value will vary. Okay, the phi value will be I think 0.7 or 0.85. It will be not 1.0. Okay, so the first thing you have to do is to calculate the demand. So please remember that we are using two approaches. One is LRFT and second is the AST. So what we are going to do, we will calculate the total load on the expected on this connection. Okay. So 102 and 68. Okay. Now this load you just add it here. Okay. Then you go for that equation, this equation. Okay, in this equation the phi value is missing. Okay, but it is added at the later stage. Okay, I will show you where they have added phi. The factor of safety for ASD is 1.5. Okay, so what we're going to do, we just have to add these values into this equation. Mu value is 0.35. Du value, I told you it is fixed. Okay, this is 1.13. HF value is for the filler plates. There are no filler plates given, so the HF value will be 1. Okay, the TB value, what is the TB value? What happened? Let me check what is going on. Okay, someone Khayab Habib, I cannot ask him, I cannot allow him. Okay, he is using a different email ID. Okay, yes, over here. So you just plug in with phi value is 0.85 here. Okay, HF value is 1. Okay, so you calculate the slippage resistance for single bolt. Okay, so what you're gonna do is you will just come to the applied loading. Applied loading on the connection is 102 kips. So you will divide this. Oh God.
सर इसकी ईमेल आईडी बंद हो गई थी, डिसेबल हो गई थी, ये हमारी क्लास का लड़का ही है ऐसा है।
अच्छा, उसको कहीं करे, मैं अलाउ कर दूंगा।
ठीक है सर।
एज पर पॉलिसी तो नहीं कर सकते, लेकिन कर दूंगा, आप कह रहे हैं। ठीक है, बता दें उसको कि दोबारा ट्राई करे।
ठीक है सर।
Acha, in the meanwhile, we will continue discussing the slip critical how we can obtain the total number of ports. So 102 is the demand and the capacity is 18.8 kips per board. So what you are going to do is you have to divide the total value by single value. Capacity, if it is a slip critical connection, so we will divide by slip resistance of the one board. Okay, so you will get a fraction value, but we will use it comes out to be 5.42 boards. So we will use even number of boards, 6 number of boards. And for AST, please remember that the demand is 68 kips. So we will also use a factor of safety, because over here we have used the resistance fee reduction factors. But in AST, we do not use material resistance reduction factors. What we use in the AST is the factor of safety. Factor of safety पे आप divide करेंगे तो it both will give you the same number of ports for the connection. So you can say that you have designed a connection now. Okay, if it had been a bearing type connection and you obtained the number of bolts, what is the next step you will do? Any idea? जब आपको बोल्ट्स मिल जाएं उसके बाद आप क्या करेंगे? बेरिंग टाइप कनेक्शन की बात कर रहा हूं. कोई गैस लगा दें? मेक अ गैस. फिर आप क्या करेंगे? फिर आप एच डिस्टेंस कैलकुलेट करेंगे, आप बेरिंग चेक करेंगे. ठीक है, वो जो हमने एग्जांपल की थी ना कि कैसे हम बेरिंग स्पेसिंग रिक्वायरमेंट चेक करते हैं. हम बोल्ट टू सेंटर बोल्ट की जो पिच है वो हम कितनी रखेंगे. तो then you have to perform all those checks. So in this way, this design problem will conclude. आपको समझ आई इस चीज की?
Yes, sir.
अच्छा अच्छा, there is a second case. In this case, it is saying that the slot holes, the longitudinal or the longer side of the hole is parallel to the applied loading. So phi value will change only. Okay. Okay. Now the same, it will say, okay, in addition, H will change because we now have long HF. This is, forget about this statement. Okay. Different documents use different uh, definitions of different variable, but we will stick to our definition, okay, of parameters which are involved in computing the slip resistance of the high strength board. So what you are going to do, you will do the same thing, okay. You will calculate the bolt, number of bolts. So you can see that if the direction of the hole is changed from short side of the hole is parallel to the applied loading, so you will get more bolts in your connection. Okay. Okay. So this is all about the demonstration. Like it was just a demonstration that we can use that the simple equation. Okay, I'm admitting it. Okay. Okay, engineer Khayab Habib. Okay, I'm admitting it. Okay. Okay, is he here in the class? Yes, his mic is off. Okay, next time, engineer Khayab Habib, you have to log in with your official email ID. Okay, Khayab. Okay. Okay, we are done with the slip critical connections. Okay. Any question from your side now, up till now?
No, sir.
Gotcha. Is all of the things are clear to you, like how we can evaluate a slip critical connection? Are you guys agree that We have sufficient knowledge or sufficient information, we can work with a slip critical connection.
Yes, sir.
Okay, thank you very much. So we come to the welding. Okay, now we will discuss welded connections. Can we take a break for 4 to 5 minutes?
Yes,
Actually,
sir.
I'm not feeling well. I have a throat and I have some temperature as well. But can it will be breather for me as well. So you can think of what we have discussed, and if you have any question, so you can note it down and then you can ask me. Okay, don't shy in asking questions. If I don't remember, I don't mind asking any question. Okay, if I don't know the answer of your question, I can go to a book, I can ask experienced person. So it is not a big deal. Okay, so you should ask questions, you should clear your mind, because you are spending a lot of time, you are giving 3 hours, so you should clear that. Don't wait for the midterm. Okay, then people say that we will see the recording and then we will do the problems, or it is very easy. So don't do that. Okay, so you should clear your head during the class. Okay, so we will take a break for 3 to 5 minutes. Okay, so I can come back. Okay, I will be in the classroom, but I will just try to relax. Okay. Okay, we will start over again. Any question in your mind, or do you guys have any question you want to ask? Okay, I think you guys have no question. So we will continue discussing our agenda. So next on the agenda is the welding, okay? Welding is a process by which steel members are connected. Please remember that what is welding? Welding is a process by which we connect our steel members, okay? And this is done by the heating them under pressure, which causes fusion of the connected parts, okay? Like welding is a process by which we connect two different steel members under heat and pressure, and this heat and pressure causes fusion of those connected members. Okay, we apply pressure, we apply heat to the steel member which we want to join, and this pressure and heat causes fusion. Okay, fusion of those steel members, and this fusion causes joining of those two members. Okay, there are different versions of welding definition. Okay, one other version I will give you is that welding is a process by which steel members are connected, uh, they are heated and fused with a molten filler material. Okay, like welding process involves additional filler metal, or it does not involve any filler metal. Filler metal means that in addition to the two members which we want to connect, we want to have another steel deposition. Third, we want more steel. So this steel is coming from an electrode, and that electrode steel we call filler material, okay, or filler metal. Okay, what happens that when we heat up the members, and upon and we do the welding, or welding process is completed. So what happens that this metal, or the heated portion of the connected members, cools down, and it becomes a part of the parent metal. Okay, for example, like if you have added a filler metal into your in the welding process, so what happens that filler metal becomes a part of the parent members. Okay, so when the load is applied on your structure, so it will behave as a part of the steel member. Okay, so there is another definition of the welding is that heating metals to fusion temperature with or without addition of weld metals. And this weld metals comes from the electrodes. Okay. Now there is a code and specification for welding, and it is known as American Welding Society. So we have to carry out, or we have to follow the specification or the standards laid out by the American Welding Society. And this welding society is being referred to by the our specification. What is the name of specification we are following in this course? स्पेसिफिकेशन कौन सी यूज कर रहे हैं हम?
AISC sir.
Yes, AISC refers to AWS. Okay, this is being referred to by AISC, that you should use for welding. Okay, great. Now there are different types of welds, okay, based on their shape, okay, and based on their methods, how they are constructed. Okay, the first, there are four distinct types. Please remember, the first is the groove weld, a fillet weld, a plug weld, and a slot weld. So fillet welds are of triangular shape. Okay, and we will discuss design of fillet welds in this course. Okay, design of fillet welds. in this course, okay? But for the sake of completeness, you should know apart from fillet welds, we have groove welds, we have plug welds, we have slot welds. Okay, now you can see that how a groove weld is will look like. For example, you want to join these two steel members, so but you have to make a groove between these two steel members. Then you have to add the weld metal. Okay, this weld metal, where it comes from? It comes from electrodes. Okay. Okay, anyhow, sorry for my spelling. Okay, so you need to have an opening between the two parts which you want to join in order to make a groove weld. Then you have a fillet weld. Fillet welds are in triangular shape, you can see in this figure. Like they can be used to join two surfaces, but these two surfaces should be at right angle. Okay, you should remember that fillet welds you can use for those members with which are that are at right angle. Okay, right angle means that the surfaces you want to join of any two members should be at right angle to each other, so that this triangle can be formed. Okay, so this size of this triangle in fillet welds is called legs. Okay, so fillet welds can be equal legged. Okay, a fillet weld can be equal legged, it can be unequal legged. Okay, yes. Okay, then the efficiency of the groove weld is superior than the fillet welds. Okay, they have a greater resistance to repetitive stresses. Okay, and they require less welded material as compared to fillet welds. Okay, but then why we use the fillet welds, not the groove welds? Okay, why? Because fillet welds are often used in structural members because they are easy to make, they are easy to construct. Who will make a groove in the members and then deposit the welded metal? So it is very easy. You take two members, you place them at right angle, and you make a weld, a fillet weld. Rather than cutting it to the specific or delicate tolerances, if to in order to get the groove, first you need a groove. Okay, fillet weld does not require a groove. Okay, so that's why people prefer, or in the field you will see that mostly fillet welds are being used. But remember that groove welds are more efficient than fillet welds because they require very little or very less welded metal as compared to fillet weld, and they have greater resistance to repetitive stresses or impact loads. Okay, so apart from the groove and the fillet welds, we have plug welds, we have slot welds. And plug welds, we have a circular holes, and by these circular holes, for example, you want to join these two plates, what you have to do, you have to make a hole, okay, in this, and then you have to deposit a weld metal in these holes. And if the hole dimension, it is a regular hole, so we will call it a plug weld, it's a plug. And if the holes are elongated, we will call it a slot weld. Okay, please remember these four type of welds, and our concern will be on the fillet welds. Okay, so you can see in this slide the all four type of welds. Okay, the groove welds. Okay, you need a groove. Fillet welds, you need to, they are of our concern. So we will do the design of fillet welds in this course. Okay, fillet welds. Okay, fillet. Okay, it is fillet welds in this course. Okay, we will not study groove, or we will not study slot or plug. Okay, so based on the position in which the weld metal is deposited, the welds can be also classified into four types: flat, horizontal, vertical overhead. Okay. Okay, what is meant by flat? Flat is meant that when the weld metal is executed from the above, like from here, you are placing an electrode, okay, and you are depositing the welding metal from the above, okay. So how the flat position is designated? It is designated with 1. When in a drawing you see 1, it means flat position. If you see F, it means fillet weld. If you see a G, it means groove weld. Okay, 1F, 1G. So the second type of the welds based on the position in which the welded metal is deposited, we call horizontal. Similar to flat weld, but the weld is harder to make. Okay, like horizontal. This horizontal. 2 means horizontal position. Okay. So the third is the vertical position. Okay. 3, if you see 1, it means flat. If you see 2, horizontal. If you see 3, and if this number is accompanied by some alphabet F or G, so it will indicate the type of weld. Okay. And the fourth is the overhead. Overhead is the fourth one. Okay. Yeah, like you are doing it, welding it from here. Okay. So this is the most difficult type of weld. You need an skilled person or skilled welder to do this type of welding. Okay. And please remember, we will discuss later that the size of the weld is also dependent upon the size of the parts which you want to connect. For example, you have two members. Okay, this member we can designate it. We will see in the next slides. Okay, for example, you want to connect them with a fillet weld. Okay, this is a fillet weld. Okay, this is a weld. Let me shade it. So the size of this weld depends upon the size of this thickness of member. Okay, if the thickness of member is more and the thickness or the size of the weld is less, what will happen that, so there will be some tensile forces which will be induced in the weld, and this weld will result, or this will crack. Okay, cracking will be produced in the weld. Okay, if the thickness of the member is very large compared to the size of the weld. Okay, so we will see that in the coming slides. Okay, so now this slide is showing that how a butt joint will look like, or like there is a symmetrical load transfer here in this joint. So these two plates are connected by making a groove and depositing welded metal here. Okay, so you can see a fillet lap joint constructed with the help of a fillet weld. Okay, so these are the just joints like in welding. Like we know that there are two types of joints. We have butt joint, okay, and we have this lap joint. Okay, in butt joint you have symmetrical loading, and in this lap joint we have unsymmetrical loading. Okay, so similarly in this slide you will see, you are seeing a T. Now this T we can make by making a groove, and we can also do it with the help of fillet. Okay, so over here it is showing that this T has been constructed, or these two members are joined with the help of a groove. Okay, similarly a corner joint, you can be a groove weld or it can be a fillet weld. Okay, because the surfaces are at right angle, so we can also go for the fillet welds as well. Okay, now this comes to the welding processes. Like welding, we know that welding is a technique by which we join two steel members under pressure and heat. Okay, and by adding uh, welding metal or without adding weld metal, you can say. So there are three types of welding, okay? So please remember that there are three types, there are many more types. So in this course, we have this forge welding, okay? In forge welding, what we do that we heat up the steel members, and then we hammer them together in order to weld them together. If you follow this procedure, so what you have to do that you will we will call it a forge welding, okay? And then we have resistance welding, okay? Then we have fusion welding, okay? There is a lot of theory based on the welding types in this lecture, and please remember that for our concern, so there are two types of welding procedures so we will follow. The one is known as SMAW. This is called shield metal arc welding, okay? So this is of our interest. And what else we have? We have submerged arc welding, okay? Submerge. Okay, what happens in the shield metal arc welding, that the pieces you want to join, okay, like for example, you want to join two pieces, okay, or you are doing a welding with the help of an electrode, okay? Now this is an electrode, and electrode you deposit this welding metal onto this base steel. So this electrode is coated with flux, okay? This electrode is coated with flux, okay? This is an electrode, okay? So what happens that when the metal is deposited onto this metal, what happens that this metal is very hot. It also causes melting of this parent steel member as well. And when you start depositing this material, it will immediately react with the oxygen and nitrogen in the atmosphere, okay? And we do not want the oxides and nitrates oxides to be formed, because they will try to embrittle this weld, okay? So what we do that this we coat the electrode with some certain flux. When this starts melting, so a gaseous field is formed around where we want to do the welding. So there is a gaseous field is formed, okay? This gaseous field will provide a protective cover, okay, protective cover for this metal, and this so that this metal will not react with oxygen or nitrogen which are present in the atmosphere. So this we call the shield metal. Shield is provided, okay, gaseous shield. And the second is the submerged arc welding, okay? In submerged arc welding, flux, as I told you that in the shield metal arc welding, flux is being coated outside of the electrode. And in the submerged arc welding, flux is provided, is supplied separately. Okay, separately. And the arc over here, remember there is an arc, okay, which is arc, and the electrodes are submerged. Arc and electrode are submerged in the flux, okay? So this is we call submerged arc welding, okay? This welding we do it in the field, okay? And this technique we follow in the shop. Okay, shop welding technique. So the what is forge welding? It consists of simply heating the pieces above certain temperature and hammering them together. So this is called forge welding. Then we have resistance welding. I'm sorry, my resistance welding is metals in resistance welding. Metals parts are joined by means of heat and pressure, which causes fusion of the parts. Okay. Now heat is generated by electrical resistance to the current of high amperage and low voltage passing through the small area of contact between the parts to be connected, and in this we have an arc, okay, which is produced, which causes melting of the parent material and electrode. Then we have fusion welding, okay. Then we have metal arc welding. Metal arc welding is in metal arc welding, an arc, okay, a spark is sustained between the metallic electrode and work to be welded. At the instant the arc is formed, the temperature of the work at the tip of electrode are brought to melting point. As the tip of electrode melts, okay, so we have deposition of this molten metal from the electrode. So the molten metal, please remember, this is important, this is of our concern, that when the molten metal is exposed to air, it combines chemically with oxygen and nitrogen, forming oxides and nitrates, which tend to embrittle the welded metal and makes it less corrosive resistance. So tough welds are produced if the molten pool is shielded by inert gas, which employs molten metal and tip of electrode. So that's why in shield metal arc welding, we use an electrode which is coated with flux. Okay, inside there is a metal and coated with flux. So this flux will produce an inert gas, okay, which will protect this molten deposition from reacting with an oxygen or nitrogen in the atmosphere. So this is a process, okay. You need an electrode, okay. There is an arc, okay. So these are the gases, okay, which are produced due to the coating, flux coating on the electrode, okay. So these gases prevent this molten metal to react with the nitrogen and oxygen, okay. Nitrogen and oxygen in the atmosphere. Okay, this is that shield metal. When an arc is struck between the metal rod and the workpiece, both the rod and workpiece surface melt from weld pool simultaneously. Melting a flux coating on the rod will form a gas and slag, which protects the weld pool from surrounding atmosphere. Okay, this is we already have discussed. Okay, then we have submerged. Okay, in submerged arc welding, we have a bare wire which is fed through the welding head. Welding is shielded by the blanket of flux which is fed onto the work area by gravity in an amount sufficient to submerge the arc completely. Okay, the arc is submerged. Okay, okay, okay. Then there is a flux core arc welding, so you can go through this. Okay, we have a MIG welding. Okay, we have tungsten arc welding. Okay, tungsten arc inert welding. So that's okay. I will try to look for a video for you, okay, in order to explain the submerged arc or shield metal arc welding. Okay, I think it is about 9:15. So can we take a break now?
Yes, sir.
Okay. In the meanwhile, I will look for the videos for you guys. Okay. So we will meet at 9:30. Okay.